here we go, last combination. This is going to be ray tracing. And this one is for a concave lens with the object inside the focal length. Again, I'm going to say a convex lens, a concave lens looks like this, and I'm going to represent it with just a rectangle because that's going to make life a little bit easier. So I've got my lens and I'm representing that with a rectangle. I'm going to draw a couple of pieces in here. So let's see, here is a line through the middle. And here is a principal axis. I'm going to put my focal length at 30 centimeters. So I will mark that spot. So this is 30 centimeters. This is 30 centimeters. On either side, it is a concave lens. So this one over here is my real focal length, focal point, and this one is my F prime over on the right, and I want to put my object at a distance of 20 centimeters. I will give this thing a height of 10 centimeters, where centimeters are dots. So I have a focal length that is negative 30 centimeters. I have an object distance that is 20 centimeters, and I have an object height that is 10 centimeters. I'm going to draw my first line, first ray, and that is going to go parallel to my axis and then through F. So parallel to my axis, looks like that. And then through F would be that. So I get an exit ray that looks like this. There is ray 1. Ray 2 is going to go through F prime, then parallel. So it's going to go through F prime, which is really only to here, and then parallel. So that's going to go this way. Those are my first two rays. Those rays are clearly not going to cross, so I'm going to have to start tracing things back. Ray 2 I can trace back, and that's going to look like that. That is my 2 prime, and ray 1 I trace back, and I'm always tracing back the part that exits the lens. So I'm not tracing the left side stuff back, I'm tracing the right side stuff back. That's my 2 prime. Those cross at this location, so that is my image location. And now I can figure out some things with this. My D image is going to be negative 12 centimeters. My H image is going to be 6 centimeters. And now I just want to check my numbers. My magnification would be HI over HO, 6 centimeters over 10 centimeters equals 0.6, and it's a positive number. It's positive because this is an upright image. And this image was formed by my prime, by my prime rays going back, which means this thing is a virtual image. It's smaller than my object, so this is reduced. And I got a magnification of positive 0.6, which tells me all of those things are true. I can also get my magnification from negative DI over DO. So let's see what that is. I get a negative 12 centimeters over 20 centimeters. 12 over 20, that's 10. That's 6 over 10. Negative and negative cancel. I get a positive 0.6, which checks out. My magnification makes sense. So some summary. And let me get rid of this background. In summary, for a concave lens, I'm always producing a virtual image, always an upright image, always a reduced image. And that is regardless of whether my object is inside the focal length, outside the focal length, or right on the focal point.